Today we're going to talk about this this lesson that I usually refer to as HLLS and SAAS. It's all about this situation that is illustrated here. All right, so we're going to go over this for a second because this is critical to the lesson. When you have this picture, all right, now it could be rotated or flipped or whatever, but it is always this picture. Different letters it could be. When you have a right triangle ABC, so the big triangle is a right triangle. See the right angle symbol. With an altitude, CD, so from the right angle down perpendicular, altitudes always intersect the opposite lines perpendicularly, drawn to the hypotenuse. So the altitude goes from the right angle to what's referred to as the hypotenuse of the right triangle. When it is this picture, these two proportions that are misspelled versions of the words HLLS and SAAS get used. And it's a very easy way for students to understand the proportions and make sense of it and be able to get some easy points. So first, you can't do any of that till you know what all these letters stand for. So this guy here, AB, is your H, right, for your hypotenuse. Okay? Now, in a right triangle, you always have the hypotenuse across from the right angle. Okay, fine. The other two sides of the triangle are referred to as legs. Now, for the sake of differentiating between these two, I'm going to call this leg 1, and not surprisingly, leg 2. Okay. We called CD the altitude, right? So that's going to be your L and your L there, right? Your altitude, I'll underline that, LTITUDE. Of course, I ran out of room. Sorry about that. All right. And then these two pieces, which together make the hypotenuse, your hypotenuse is split into two different segments. So this is going to be segment 1, not because I wrote it first, but because it's attached to leg 1. Segment 1's attached to leg 1, which obviously is going to make this segment 2. All right, so segment, altitude, leg, hypotenuse. Okay, so with all that in mind, here's your first of the two acronyms, I guess we'll call them. SAAS. All right? SAAS says that the altitude is what's called the mean proportional between the segments of the hypotenuse. All right? Well, okay, we got two segments. So I'm going to adjust this right here to say segment 1 and segment 2. Now, as a quick reminder, a mean proportional in a proportion is when the bottom left and top right pieces of the proportion are the same. All right, so your altitude, if it goes in the bottom left, it goes in the top right as well. All right, now, all this means is that if you know a segment, and the altitude, you can write a proportion between them. But more than likely, what you're going to have is the altitude in one segment, and you'll have to figure out the other. All right? Or you'll have both segments and you have to figure out the altitude. All right? So but the first thing is, like, you're going to have to say, oh, okay, I know this picture makes it HLLS and SAAS, but now it's, well, is it HLLS or is it SAAS? And the answer as to whether or not it's SAAS is the easiest one of the two. When to use SAAS? When the altitude is, quote, involved. And what I mean by that is given or asked for. So if you're being asked to solve for the altitude, it's SAAS. If they give you the altitude, and you're talking probably about the segments then, it's SAAS. All right? So you're going to first make that determination. Once you decide, hey, this is a HLLS and SAAS question, then you'll try to decide if it's SAAS. All right? So you'll write a proportion, you'll cross multiply, you'll solve it, and we'll do examples at the end. Okay. The other misspelled acronym is HLLS. Notice there's no I. Right? So what that's saying is that either leg of the right triangle, right, is, again, here's that term, mean proportional between the hypotenuse and its adjacent segment. All right, so in case it wasn't clear before, SAAS, S over A over S, SAAS. That's how you write it. So same thing here with hills. HLLS, H over L, L over S. All right, equal sign in the middle, of course. So you're going to really kind of almost look at this with two different proportions, though. I'm going to try to somewhat neatly draw this here. Now, you have your hypotenuse. We call this leg 1. We call this segment 1. So you're really going to have a hills for leg 1. So that's your hypotenuse over your leg 1. And that's equal to, again, if it's mean proportional, bottom left, top right have to be the same. Leg 1 again, over which segment if you're dealing with leg 1? It's got to be segment 1. All right? Same scenario here. Again, you have your hypotenuse. This was leg 2, this was segment 2. So you could also write hills for leg 2. So that would be hypotenuse again over leg 2 equals leg 2 again, mean proportional, and then it's over segment 2. So the annoyance of this for some kids is, oh, wait a second. If I look back here, I got 2 legs, right? And this one, hills, has 2 legs in it. So it's got to be 1 and 1, but it's not, all right? This is specifically the same leg, all right? And this is the segment that goes with that leg, all right? So in that case, you just have to pick which one, and the amount of information that the question gives you is what's going to dictate which you use. Now, this isn't going to sound all mathematically fancy here, but when do you use hills? When it's not SAS, all right? You'll see the altitude's not going to be involved, and you're going to say, oh, then it must be hills, and it will be hills in that situation. So, you'll see. All right, I'm going to end there. The examples are really what should help you the most, and we'll take it from there.